Hi, everyone. I'm Russ Lowenthal. I'm Vice President for Database Security here at Oracle. And today I want to talk to you a little bit about four simple things that you should be doing to secure your database. Now, we all deal with lawyers. Because I work in development, I know kind of what's coming. And if at any point during this presentation I happen to talk a little bit about something that may be coming in our next release of the database, that's just me talking. Things always change in development. You can never count on it. That's what the safe harbor slide means. But everything I'm telling you is everything I'm going to tell you. It doesn't matter what version of your database you're on. It really doesn't even matter if you're using Oracle or not. Most of the things we're talking about are universal for any data-driven application. The examples that I'll give are specific to Oracle, but the concepts are just simply universal. So how do you secure a database? Basically, there are four things that you need to do. The first one is you need to understand how your system is configured. You need to look at the configuration parameters, the setup of your database, and the Oracle database in particular. There are lots of different configuration parameters, and most of those have nothing to do with security, but there are a few that if you set them in a certain way, they change the way the database behaves from a security standpoint, and they can introduce unnecessary risk. You want to find those settings. And if you are accepting additional risk, you want to make sure you do that with your eyes open. You don't want to be blindly accepting things and not knowing what's going on. So you assess your database to find and remove unnecessary risk. The second thing you do is obvious in today's world. You need to encrypt your data. Encryption is a fundamental security control, and that means your data as it travels over the network. It also means your data as it is stored within the database. All data should be encrypted pretty much all of the time. You need to control access to the data. You don't want, well, in most cases, everyone who can access your system shouldn't be able to access all of the data within that system. They should be able to see the data that is relevant to whatever business they have to do, not all of the data. So you control access to the data. And then the final thing you've got to do is you've got to plan for failure. The bad guys are out there. They are definitely trying to get at your data. You want to assume that they are going to be probing your defenses. And you want to audit what's going on in your database for two big reasons. One of them is maybe through your auditing, you catch what's going on before something bad happens and you're able to stop it from happening. Or maybe you don't catch what's going on, but later you can go back and reconstruct what the bad guys did so that you can determine what the amount of damage was. What was the blast radius of this type of attack? Let's take these four different things individually. We'll start with adopting a secure configuration. Like I said, the database has dozens of settings that impact security, and you want to make sure that you're controlling your configuration so you don't expose additional risk. Now, there are a couple of tools in your toolbox that can help with this, all right? One of them is the Database Security Assessment Tool. Others include things like DataSafe or Enterprise Manager configuration dashboards, but we're going to start with the Database Security Assessment Tool. It's basic, fundamental, very, very easy to get to. It's a command line utility that really is a lowest common denominator. If you have access to your database, you can run the Database Security Assessment Tool. All right, so let's look at this. We start by going to My Oracle Support. We go to the support note that talks about Database Security Assessment Tool. We agree that we're going to, abide by the terms and conditions, and we download the assessment tool. It's a simple zip file, very, very easy to use. Once we've got it downloaded, you can see it's a pretty small file. We transfer that out to our database server, and we unzip it. We've got to make sure that we meet the prerequisites. We need to have Python. We need to have, obviously, the zip and unzip utilities, and we need to have Java 1.8. First, we'll go ahead and run the Database Security Assessment Tool collector. We'll give it the credentials to connect to our database and what we want our output file to look at. We give it the password for our database, it runs, and then it produces a zip file that we're going to encrypt. That's what the second password is. Next, we analyze that collected data. We run the Database Security Assessment Tool reporter. We tell it where our file is located. We give it the password we used when we created the file. We give it another password. This time it's going to produce our output file, and that includes text, HTML, spreadsheet, and JSON format demos. We open up the HTML, and here you can see an example of what a security assessment looks like. And we've just gone through and we have checked everything from user profiles to is the latest patch applied, to how are your passwords being managed, to all those initialization parameters that deal with security. And we tell you, we found this area. We think this is an area of risk. In this case, we're looking at something that's medium risk. We have users with no password verification functions. We can also look at this through tools like DataSafe. If you're running in the Oracle Cloud, you might be using DataSafe, and there you can run a report. You get a little bit nicer dashboard, and we can easily compare assessments from one to another. But these all do the same basic thing. They tell you where you've got risk, where you've made configuration choices that perhaps are introducing risk that you don't need to accept, and give you a clue of how you can back out of that risk if you want to. DataSafe has a little bit of extra things in there. For example, we also do user assessment. We look through your users, say which ones are the highest risk if they were compromised, what their access is. You can even drill down and see what their activities are and what their individual privileges are, as well as alerting when new privileges are granted or new users are created. But assessment, first thing we do from a security standpoint. Next thing we want to do is encrypt our data. We encrypt our data in motion. And for this, you have industry standard transport layer security. Transport layer security means that you have to, at a minimum, issue the database a certificate. And then you can choose to set up mutual transport layer security where the client also has a certificate, or you can choose not to. You also have native network encryption, which is old technology, been around a long time, but we do keep it up to date with the latest encryption algorithms. And this allows you to encrypt without certificates. Obviously, TLS with certificates is more secure because the database is identified by a certificate, but there are operational things you have to think about when you're managing certificates. So oddly enough, native network encryption is very, very popular, even with security conscious organizations, because you don't have things like the risk of a certificate expiring. All right, for data at rest, you're normally going to encrypt using transparent data encryption. Transparent data encryption is one of the features of Oracle Advanced Security, an option for the Oracle database. Let's take a look at encryption and see how this works. And what we're going to do is we're going to start with the database. No user table space is created at all. No real data in there. It's a fresh database. We're going to create two table spaces. One of them is a clear table space. One is encrypted. When we look at these two data files for the table spaces, there's no data in the clear table space, no data in the encrypted table space because we just encrypted it, or just created it rather. Now we're going to create a table in each table space, and all we're going to do is create that table, and then we're going to insert a single record into each table. We're not going to commit, so we still expect to see no data here. We look at the data files, we do a quick strings on it, and when we check this, there's no data in there. This is to be expected. Now we'll commit and do a checkpoint to force the database to write to the files. And we'll go out and we'll take a look at our table spaces again. When we look, we can see the clear Russ was here, but the encrypt doesn't show up at all. If we look at that clear table spaces data file, there's our test clear Russ was here. When we look at the encrypted data file, remember there was nothing in there before, look what we see now, a bunch of gobbledygook. This is encrypted data, and this is how simple encrypting the data is with an Oracle database. The third thing we want to do, is we need to control access to data. This is probably the most interesting thing that you get to work on because there are so many ways to control encryption, because there are so many ways to control access in an Oracle database. You can control it based upon data attributes, on session attributes, on objects, on commands. There are so many features to do this, but one of my favorite is something called database vault. And this is an area where you get a lot of power with the Oracle database. So let's take a quick look at Database Vault. And again, we're going to start with the database where Database Vault isn't even configured. I'm going to take you from zero to hero in one step. So here we can see no Database Vault configured, and we will go ahead. We will create a Database Vault owner and a Database Vault manager. These are for separation of duties. Once we configure Database Vault, these users will be used. We'll grant permission for these guys to log in and create a session, and that's all we need to do. Now, what we're going to do is we're going to configure Database Vault. And notice that I'm doing this as sysdba. Takes just a second. And then what we're going to do is we are going to log out as sys and log back in as the Database Vault owner. Okay? But before we do that, let's go ahead and check to make sure that we're in the right container. We'll make sure that we don't have any invalid objects out there, because when we run Database Vault, it does a complete privilege recheck. And now we'll close our pluggable database because we've made this configuration change and we want to restart it with the new Database Vault configuration going. So we bounce our pluggable database. We'll go back to SQL Developer. Because we closed and restarted the database, I've got to reconnect. So I'll reconnect as my different users that I'm logged in as. And you'll notice that I've got several different sessions here, so make it easy to switch back and forth between sessions here in the demo. Now, all we've done so far is enable Database Vault. That did a few things. It instituted some basic separation of duties. SysDBAs, for example, can't create users anymore, but I haven't done anything really to protect data yet. So when I go in and I look at a table like this that obviously has some sensitive data in it, I can still see that. I can see that as a DBA. I can see that as someone who has granted direct object privileges to it. And of course, I can see that as the schema owner. Now I'm going to go in as the Database Vault administrator, and I'm going to put some security around this. The first thing I'm going to do is I'm going to create a realm, a logical construct to hold security privileges. And then I'm going to go through and I'm going to add the entire application schema to that realm. And I'm going to grant only the application owner access to that schema. No one else can see it. And by no one else, I mean DBAs, people who have direct object grants. Database Vault overrides everything. So I'll go in and I will change my session, and I'll try logging in as someone with direct object privileges. I can't see the data. Okay, insufficient privileges. I will change and I will become sys. DBA, can't see the data. And here what I've done is in just a few minutes, I have protected this application data, which in most cases is sensitive data, from these compromised privileged user accounts. Because, we didn't really go into a lot of setup for this, but the way most databases get hacked is someone actually compromises an account and just logs in and steals the data. And administrator accounts are the favorite ones to compromise. So here we've got Database Vault and we've controlled access. The fourth thing we want to do is we want to make sure that we are auditing what goes on in our database to support those two use cases. One, maybe detect something before it gets out of hand. Two, something does happen. We want to be able to go back and see what happened and what data was accessed. For that, what we're going to use is Unified Audit. Unified Audit was brand new a decade ago, back in Oracle 12. Now, it's pretty old, very mature. But what we're going to do is we are going to use Unified Audit to audit some common security issues. If someone tries to log into the database and fails, well, we want to know that. That's a good security event. If someone creates a new user or tries to create a new user or grants roles to that user, we want to know that. That's a security event. And if someone is changing structures within the database, changing the definition of the data, we want to know that too. Here, our main tool is built into the database, Unified Audit, but optional tools would include things like Audit Vault and Database Firewall, or the auditing capabilities of DataSafe, where we're going to collect this audit data from the database and move that into a repository for analysis, alerting, reporting, all of that stuff that we need to do from a compliance standpoint. So let's take a look at auditing in action. And We'll start again, clean system. I've purged the audit trail. There's no real data in there. That one record you see is the fact that I purged it. That always gets audited when you purge your audit trail. But all set to go. And what I'm going to do is I'm going to connect to the database as someone with privileges to control auditing. Okay, so you can see I'm an audit vault administrator. I'm sorry, I'm an audit administrator. And I'll again check to see what roles I have. And I have that audit administrator role. And I'm just going to go ahead and turn on 3 of the default audit policies: logon failures, anything that has to do with database vault, and any of the secure configuration stuff. These are now all active and they're ready to capture activity. So let's create some activity. I'm going to go in and I'm going to try, notice I'm sys, I'm going to try and create a user called Bob. Now remember, I turned on database vault in our last piece of security. So this should fail because DBAs can't create data anymore. And sure enough, it does fail. Generated an audit record. All right, let's see, what else could I do? I could try and go in as a different user. And this time I'll go in as the database vault account manager. And I will create Bob, but this time, because I'm the right user, I do have the privileges under database vault to do that. This one will succeed. Again, it's going to generate an audit record because I said to audit this type of activity. I'll grant privileges to Bob, create session, okay? I'll grant a role to Bob, DBA. All of these things are creating an audit trail so that I can see who did it, when they did it, where they did it from. Go back to sys, I'll grant DBA. Before I failed because I didn't have privileges to grant DBA, I was just the user admin, okay? You can see our audit records. And when we kind of scroll over and look, it's a pretty wide table. There's a lot of data in that audit table. We can see some things were done as the database vault administrator, some were done as the audit administrator, but we can see someone did something to Bob, someone had a logon failure. All of these things were audited along the way. Okay, let's do a little bit more. I'm going to try and log into the database. And I'll log in as Bob with a password of Bob, which of course is not my password. You watched me use a more secure password when I did this. I'll try connecting as Joe with a password of Mary. And again, this is not going to succeed because that's not Joe's password. I don't think I've got a Joe in this database. All right. And we go back and again, we look at our audit trail. And we can see, sure enough, if we scroll over just a little bit, that we came in from a different client as different users, and we tried to do different things. If we look in DataSafe, same type of information is available, but again, you get a little bit more with it. You get the ability to generate reports and do analytics a little bit more easily. And you can generate alerts when certain things happen. So DataSafe gives you more to this, but you've got all the tools you need inside of your database. All right. So here's our records. And again, you can see that complete record, everything that happened as we were doing our audit activity. All right. So that's it. I told you it was 4 simple things, and it really is 4 simple things. You need to make sure you understand your configuration. You need to monitor your configuration. If your configuration changes, you should be checking it periodically so you know about this. A lot of breaches happen, not just because of compromised accounts, but because someone forgot to apply a patch or changed a setting while they were troubleshooting something and forgot to change it back. So check your configuration, not as a one-time activity, but as a periodic, ongoing standard security process. Encrypt your data. At rest, in motion, data should be encrypted. Control access to the data. And I showed you one tool, Database Vault. There are lots of different ways to control access. They have different advantages and disadvantages and use cases. You can spend a lot of time here. And finally, audit access to your data. I did cheat with one thing. I tried to keep this as clean a system as I could, but because I'm in multi-tenant, because I'm using a pluggable database, just full disclosure here, when I enabled Database Vault, before I had done that, I had already enabled Database Vault in the container database. With multi-tenant, you can have Database Vault just in the container, or you can have it in the container and the pluggable. If you just have it in the container, mainly what you're doing there is preventing container administrators from seeing pluggable data. If you have it in the pluggable, that's when you get those finer grained rules, like I was saying. Uh, I very carefully, when I was talking about auditing, didn't say the fourth and final thing because there's no such thing as final when it comes to security. There is always more you can do. When you've got these four simple projects done, here are a few other things you might want to consider. Key management for your encrypted data. This is for the data at rest. Encrypting is really easy. It is exactly as easy as I showed you. You create the encrypted table space, you put the data in there, it's automatically encrypted. When you select it, the database automatically decrypts it if you have privileges to see it. Key management takes a little bit more work. The default way that a lot of things store keys is on an encrypted file within the database server. Now, think about this. You're encrypting the data to protect someone who has operating system level access from seeing those data files and seeing the data that's in them. Does it really make sense to have the encryption key on the database server? Usually not. That's why you need things like Key Vault so you can move the encryption keys outside of the database server. Take a look at Key Vault if you're on premises or OCI Vault if you're running your databases in the Oracle Cloud. A lot of us copy our production databases back to non-production test and development systems. If you're doing that, you can do everything I just talked about, but that may lock down your development system to the point where the developers can't practically use it. Also, evaluators, auditors tend to be a little bit upset as you begin to proliferate sensitive data into multiple repositories, because every time you add a copy of a database, that's just one more chance for that data to be accessed and stolen. So a very good security technique is to scramble the data in your non-production copy of the database. Tools that can do this are things like DataSafe or Enterprise Manager's data masking and subsetting. And then another project, and this one is really, really popular in today's world, is take a look at how your users are authenticating. I was showing you username and password. Not the best way to authenticate to a database. Try and go beyond passwords. Your Oracle databases support Kerberos authentication, certificate-based authentication, Radius, which is a real common way to get to multi-factor authentication. We support tokens. We started doing this a couple of years ago in 19C. Azure AD OAuth 2 tokens and Oracle Cloud's IAM tokens. All of these are better options for database authentication that can reduce the risk that an application account gets compromised or a user account gets compromised and improve your security. So where you can, shift from using username and password to stronger authentication. If you want to play around with this, everything I've shown you, you can get hands-on for free. Our GitHub repository, that's listed here on screen. If you look all the way over on the right-hand side, you'll see something called Live Labs. Live Labs is a wonderful resource because not just security, but most things at Oracle that have to do with the database, there is a hands-on lab out there where you can check an environment out from our cloud on our dime and go through and practice with that environment and learn how to use the features. If you're specifically interested in the security labs, bit.ly/go-live-labs-dbsec will take you there. And if you really like security, the second Wednesday of every month, my team, my product managers, host office hours. And bit.ly/asktomdbsec is how you can find out what the schedule is for the office hours, what the topic is for that month. If you can't attend live, you know, it's a global world. You could be sitting somewhere around the world from where we're doing this and the time we're holding office hours isn't convenient to you. Don't worry. We record them. We post the recordings a couple of days after the event, and you can always go back and see what's going on with them. Thanks for joining us. If you'd like to, again, if you like security, these are great resources for you. All right, and that's it. Thank you again for giving me your time today.